Regular expressions are available in many types of tools such as text editors and database engines, but their real power is when used in programming languages. One of the most common regex operations is searching for a pattern. This could be something literal like the word Geronimo, or something more abstract like phone number or email address patterns. Regular expressions provide us with tools to build non-literal patterns. One such tool is a rich set of metacharacters. Metacharacters are the key to powerful, efficient, and flexible text processing. In this video, we will learn about some key metacharacters by solving a problem statement. So let's first open Jupyter Notebook and import the RE module. Now here is our first problem. We have a string and wish to know if it contains any numbers. There are a few ways of solving this problem. One approach is using a character class. So I can create a pattern like so. This would match one or more of the characters listed between the square bracket. In this case, the digits from 0 to 9. Let's test it out. It works, but our pattern is unnecessarily bulky. So let's try something more concise. The dash in this case indicates a range of numbers from 0 to 9. So this is good, but we can do better. Searching for numbers is so common that we have a metacharacter to denote a digit, the \d. Please note that it's d in lowercase. Now we have seen 3 ways to search for digits. And just one more thing. Perhaps you did notice that the regex function tried to match as many numbers as it could in one scoop. For example, it could have stopped at the first match, but it did not. It just continued and grabbed as big a chunk as it could. We will talk about such greediness in more detail later. Alright, now let's come to a more realistic problem. I will open a file containing some data. The file contains names and among other things it contains phone numbers. So let us try and match all phone numbers. Since we know our data, let's start with a simple pattern. A phone number has an area code, a dash, and then the phone number. But there optionally could be one or more space characters on either side of the dash. So we got to account for that too. Let's build our first pattern. \s matches spaces, tabs, new lines, and more. Check the documentation for specifics. The star matches 0 or more spaces. Compare that with the plus sign that matches one or more digits in this case. Right, let's look at what we have. There's quite a bit of noise here. We did not want this number here, since the number before the dash is not an area code or country code for that matter. Similarly, the 00672 does not belong to a phone number. Finally, we are missing the plus sign from a valid phone number. So let's fix things. A phone number could start with an optional plus sign, and the country or area code could be 2 to 4 digits in length. Notice that we needed to escape the plus character to take its literal value and prevent it from being treated as a metacharacter. The curly braces after the first digit sign helps us specify a range from 2 to 4 digits. Let's test. Interesting, the only thing we have managed to fix is the plus sign. How do we fix the problem with these two numbers? Ideally, what we want to do in these cases is to check that there are no characters before the area or country code. If there are no characters, we are fine, else not. It's like wanting to cross the road but taking a quick look for oncoming traffic from the left or right before doing so. No traffic? Then cross. Is there a regex expression for this? Yes, there is, and it's called a look behind. So at this junction here, we wish to look behind and see that there are no digits or alphabets, say. The \W character matches a word. This includes upper and lower case alphabets, digits, and the underscore. So at this point, let us look behind and see that there is no word character. As an aside, please note that I put the dash before the word character. Any guesses why? Great! We seem to have captured valid phone numbers. And in the process of doing so, we have seen quite a few metacharacters. We looked at digits, words, character classes, ranges, the 3 types of quantifiers, plus, star and question mark, and of course the concept of look behind. Our pattern still may not be the best solution, but please remember, it need not be. Your regex is controlled by your knowledge of the underlying data. So this brings us to the end of this video. In the next video, we will look at some more metacharacters and the concept of groups. Thank you.